Good morning, everyone. It's Mrs. Schwartz, and I want to go through and complete Lesson 8 for you. And I do want to really stress that this is optional at this time. This does not have to be completed. I am hoping that we can sort of have a little bit more of a schedule as of March 30th. But for now, these video lessons are optional. I know that we're a couple of lessons behind the other classes because we did spend a couple of days on the algebra tiles. So I'd like to just catch us up to everyone else. But again, if you don't get these done, do not stress over this, okay? So today we're going to look at Lesson 8, the exponent laws, specifically the negative and zero rules. So we already know, I know you guys know this because we've talked about this in class and everyone is aware that anything to the power of 0 is equal to 1. So let's just investigate a little bit why that is. So the first thing here says simplify the following using the quotient law. Well, we know the quotient law says that when we divide powers with the same base, like this 2 squared divided by 2 squared, when we divide powers with the same base, we subtract the exponents. So 2 squared, 2 to the power of 2 minus 2 would equal to 2 to the power of 0. But we also know that 2 squared is equal to 4, and 2 squared is equal to 4, and 4 divided by 4 is equal to 1. So if both of these things hold true, which they do, then we know that 2 to the power of 0 has to equal to 1. So in general, we say that anything to the power of 0 is equal to 1. Now we do have to look and be careful of that a little bit because we know that our base is immediately to the left of our exponent, and if that has brackets, that may have different ramifications. It might look like it'll be a 1, but it may not be. So let's look at a couple of examples. Well, this first example, 2 to the power of 0 is always obviously equal to 1. We just did that question up above. If I look at question B here, this 0, this is what I'm talking about. The base is everything to the left, including everything inside those brackets. So anything to the power of 0, it looks frightening, but it's just a big 1. Okay? I'll let you try question A and question B. So A here, again, this 0 applies to everything inside the base, and because we've got brackets, our base is everything inside the brackets. So A is just equal to 1. If we look at question B, this might look like it's equal to 1 at first glance, but let's look at it carefully. Let's break it down. If we look at the denominator, this 0 here, okay, this 0 applies to everything inside these brackets, so this is for sure a 1. But on our numerator, this 0 here only applies to the A, okay? This 2 in front is called the coefficient. So this is like saying 2 times a to the power of 0, and a to the power of 0 is equal to 1. That's like saying 2 over 1 or just 2. Those are both the same. Okay, so what looked like it might have been another 1 up top here was actually a 2, right? Because it's a to the power of 0 times 2. Now let's look at our negative exponents. In general, a to the negative m is equal to 1 over a to the positive m. And a to the negative m is equal to a to the positive m. So what the heck does that mean? What this basically means is it means if I have a negative exponent as a numerator and I take the reciprocal and place that power into the denominator, my exponent becomes positive. I have a negative exponent in my denominator. If I take the reciprocal and move that to the numerator rather, the exponent becomes positive. So I'll do a couple of examples to sort of explain where those negative rules come from. If we look at 2 to the power of 4, we know that 2 to the power of 4 doesn't mean 2 times 4, which would be 8. It means 2 times 2 times 2 times 2, which if we expand that, we get 16. And 2 cubed, of course, is 8. 2 squared is 4. 2 to the power of 1 is 2. Anything to the power of 0 is equal to 1. And then we get to the negative exponents. Well, what do we do with those beasts? Well, if we just go by this rule here, if I have a negative exponent up here, if I have a negative exponent as a numerator, if I want, I can rewrite that by taking the reciprocal of 2 to the negative 1, and I get 1 over 2 to the positive 1. So the next one here would be 1 over 2 to the positive 2, and 1 over 2 to the positive 3, and so on, which would be 1/2, 1 over 4, 1 over 8, and 1 over 16. Another way of thinking about this, is, let's get rid of that. Hold on, now I just did something weird with my keyboard. You know your teacher and her technology. Let's get back here. I touched the keyboard. Apologies. Let's just get back to where we were here. If we look at this also with respect to the pattern, okay, 16 to 8 we're dividing by 2. 8 divided by 2 is 4. 4 divided by 2 is 2, and so on. And if we think about 2 to the 0, which is 1, 1 divided by 2 as a fraction is 1/2. And 1/2 divided by 2 is 1/4. Now, how does that work? How is 1/2 divided by 2? Let's just review our fractions really quickly. 1/2 divided by 2 is the same as 1/2 multiplied by, remember when you divide fractions, you multiply it by the reciprocal. Okay, so we're all going to have to get over our fear of fractions, which we're getting there. Okay, so 1/2 times 1/2, which is 1/4. Okay, and again, if we were to divide by 2 to get 1/8, that's the same as multiplying by 1/2, which is 1/8, and so on. Okay, so that's one way to look at our negative exponent laws, is just to look at the patterns and see if this pattern holds true, then 2 to the negative 1 has to equal to 1/2, and so on. Another way to look at that is using our product law and our quotient law. If we have, for example, 2 to the power of 5 divided by 2 to the power of 3, using repeated multiplication, then 3 2's in the denominator would reduce with 3 2's in the numerator, and we get 2 to the power of 2. Or, using our laws, 2 to the 5 divided by 2 to the 3 we know is 2 to the power of 5 minus 3, which is 2 squared. So either way, we get the same answer. If we do a division in reverse order, and we get 2 cubed over 2 to the power of 5, where our 3 is on the top, we get 2 times 2 times 2, and we've got 5 2's being multiplied on our denominator. Now we get these 3 numerator values reducing with the denominators. And remember, these are all 1 over 1, not 0. Okay, so what are we left with on the top? On top, we're left with 1 over 2 squared. Or if we think of this as our quotient law, that's 2 to the power of 3 minus 5, which is 2 to the power of negative 2, which we know is the same as 1 over 2 squared. Okay, so if we can see those and understand somewhat, then the next few examples will come easily to us. Now, what does this mean when it says simplify each of the following expressions? What that means is I want to rewrite with positive exponents. Okay, I want positive exponents. And then I'm going to evaluate, if possible. Okay, so rewrite, let's rewrite with positive exponents, then evaluate. So this 3 to the negative 5, I would rewrite that as 1 over 3 to the positive 5. Okay, question B, if I look at this negative exponent, that just says take the reciprocal of this negative 12, which is over 1. And if I rewrite that, I get 1 over negative 12 to the positive 4. Now this negative, I just want to point out, this negative inside the brackets does not change when we take the reciprocal. Okay? It's just a negative number, it stays negative. Now, because this is an even exponent, oops, it's an even exponent, that's 2. Okay, because this is even, now we can use our math knowledge that if I raise a negative number to an even exponent, it will become positive. So then when we expand this and evaluate, let me just grab my calculator here quickly. What do we get? Some big number, 12 to the power of 4. So that means 12 times 12 times 12 times 12, 12 to the power of 4, which is equal to, our final answer here should be 1 over 20,736. Okay? If we look at question C, 1 over 7 to the negative 2. Well, now my 7 to the negative 2 is on the denominator, so I want to move that up, which becomes a 7 to the positive 2, right? Our denominator is 1, which is just 7 squared, which is 49. Okay, if I look at question D, there's a couple ways to work through this, and sometimes there's more than one way. As long as we're following our exponent laws, there's sometimes more than one way to do a question. If I see this negative exponent, it simply means I take the reciprocal of the base. So our base here is 2 over 3, and if we take the reciprocal of that, we get 3 over 2 to the power of 5, positive now. And I know that this 5 applies to both numbers inside my fraction. So I'm going to rewrite this as 3 to the 5 over 2 to the 5. And of course, if I just plug 3 to the 5 in my calculator, I believe that's 243 over 32. So that's one way to work through this question. Another way is to expand this negative 5 right away into my brackets. Okay, so I can also think of this as 2 to the negative 5 over 3 to the negative 5. And then, of course, I'm going to look and say, well, this is negative. That is a negative exponent. It's on the denominator. That denominator has to go up to the numerator, and this numerator has to go down to the denominator to become positive. So now I've got 3 to the 5 over 2 to the 5, which is 243 over 32. Okay? So let's move on to the next page. And there's a little try. You guys can try these ones. Again, this negative just simply says, take the reciprocal of this power. And if I haven't written it like this yet, if I keep the 1 inside, thinking of this like that, that's fine too. But I also know that 1 squared is just 1, so we can almost ignore the 1, which is what I've sort of been doing so far. And then, of course, because this is an even exponent, then this negative 4 can become positive, right? Because a negative times a negative is a positive, so we get 1 over 16. The next one, again, I'm going to take the reciprocal and get 2/3 to the power of positive 3, which is 2 cubed over 3 cubed, which is 8 over 27. Let's have a look at the next one. Simplify each of the following expressions. So again, I see this negative 1. In order to get rid of that, I just take the reciprocal of my base, which is c cubed all over a squared b, now with an exponent of positive 1. Okay, if we look at the next one, I'm going to take the reciprocal of the base. So when I take the reciprocal of the base, this exponent changes, but the inside, everything else stays the same other than we flip them. The inside, nothing else changes. For example, what I mean is this is 5 over 3 to the negative 1. Okay, the negative 1 does not change. Only the 2 outside the brackets changes. Okay, and I can do this in another way that might explain that a little bit better. Now I say this is a negative 1. I'm going to move that to the numerator. That's 5 times 3 to the power of positive 1, all squared, which is 15 squared, which is 225. So another way to think this through is to, again, we can expand this negative 2 inside to each individual power. So we could rewrite this as 3 to the positive 2, because this is power of a power law. Negative 1 times negative 2 is positive 2 over 5 to the negative 2. Because there's a little bit invisible 1 exponent on that 5. So now I've got 3 squared over 5 to the negative 2. And of course, I know that, there's that negative exponent. I need to move that one up. And what do we get here? We get 3 squared times 5 squared, which is 9 times 25, which is also 225. Same answer, 2 different approaches. Okay, if I look at the next one, here's the negative power there. That needs to come down. And our answer here is going to be 2 cubed over 5 squared, which is 8 over 25. Okay, you try these 3 questions. I'll give you a few minutes or seconds. So our negative 2 here just says take the reciprocal. And when we expand this 2 inside the brackets to every part of this base, we get 1 over 3 squared, which is 9a squared. Okay, question B, this 2 to the negative 1 is going to come up. We get 5 times 2 to the power of positive 1, which is just 10. If I look at question C, this 2 to the negative 3 must come down. What are we left with on our numerator? We're left with 1 over 2 cubed a to the 4, which is 1 over 8 a to the power of 4. Let's look at the next one. We want to simplify. So I'd like to look at these separately. Okay, and we'll do the same thing over here. We're going to look at the numbers separately, and then we'll look at the individual variables. I've got b to the 9, and this is all multiply, right? We've got 3b to the 9 c to the negative 7 multiplied by negative 4b cubed c to the negative 6. So let's look at this separately. 3 times negative 4, well, that's just negative 12. Okay, our negative times positive rules remain the same. Nothing's changing there. B to the 9 times b cubed will be b to the power of 12. And c to the negative 7 times c to the negative 6 is c to the negative 13, right? Negative 7 plus negative 6, whoops, negative 6 is negative 13, okay? And now, again, we're going to look at this and say, well, what needs to move down? The c to the negative 13 needs to come down. So our final answer here will be negative 12, b to the 12, all over c to the power of 13. Okay, let's look at the next one. The last one here. 21 divided by negative 7, that's just negative 3. And of course, a to the 4 divided by a to the 4. Let's erase that for a second. This a to the 4 over a to the 4. Sorry, technical difficulties. That's all equal to 1. So we can just ignore that. And the b to the negative 5 over b to the 5, well, how does that work? Mrs. Schwartz is not having a good time here with my highlighter. Sorry. Let me just straighten things out here a little bit. I was doing so well. Okay, so our a to the negative 4 divided by a to the negative 4, that's just equal to 1. And then the b to the negative 5 divided by b to the 5, that's just equal to b to the negative 5 minus 5, which is b to the power of negative 10. And then finally, again, I say, what do I do with this guy? He comes down. So I rewrite that as negative 3 over b to the positive 10. So that's it for this lesson, I believe. If we go into the assignment's not too bad. I would recommend, if you want to do it all, great. I would do all numbers, but maybe the odd letters, right? Remember, which are A, C, E, G, etc. If you're bored and you have the time and want to just a little bit of extra practice, you can do all, okay? Up to you, as much as you need to do, sort of feel like you know what you're doing. Try using, no calculator. This one here says evaluate without using a calculator. So think about your exponent laws. Think about what we know. I think everyone could do all of these. This one, the explain. Explain can be a little bit tricky, can't it? Explain why negative 8 to the power of 0 is different than negative 8 in brackets to the power of 0. Why do they have different values? Well, if you look at the first one, negative 8 to the power of 0, the 0 only applies, this would be a good explanation, I think. 0 only applies to the 8. The negative 1 is a coefficient. Therefore, negative 1 times 8 to the power of 0 is equal to negative 1 times 1, which is negative 1. If we look at negative 8 all to the power of 0, the 0 applies to the entire negative 8. Therefore, this is like negative 8 to the power of 0 is equal to positive 1. Okay? And that's due to the brackets, isn't it? Right? Because of the brackets. So in this case, another explanation is probably multiple, but we could say the 8 is the base. Here, negative 8 is the base. Right? So that's another way we could say the base, the base is only 8 here. Okay? The base is 8. Here, the base, and I know the exponent applies to the base. Okay? The base is in brackets, which is negative 8. Okay? So, and the exponent applies to the base. Okay, so whatever, some kind of explanation like that would be great. Let's see, do these look frightening? Simplify and express with positive exponents and evaluate without using a calculator. So something like B, if you were to do this one, you would say 3 to the 0 plus negative 3, because this is product law. We're multiplying powers with the same base. We add the exponents. That's equal to 3 to the power of negative 3. So I want to rewrite with positive exponents. So I would write that as 1 over 3 cubed, positive 3. And then that would be 1 over 27. So there's kind of two parts to this answer. There's the positive exponents, and then there's the 1 over 27. Something like 5b. Let's look at 5b, and D looks frightening because there's a weird fraction in front there. Scary. So let's look at B here. What is negative? Well, both of these parts are negative. So I would move them both down. So our answer here is going to be 1 over c squared x to the power of 5. If we look at something like D, D is just simply a fraction 2 over 3 times by b to the negative 8 over 1. So if I multiply those, I've got 2b to the negative 8 all over 3. Now what portion should come down? This b to the negative 8, because that negative 8 only applies to the b. There's no brackets. So we end up with 2 over 3b to the positive 8. Okay, and I bet if you guys were to work through these, you would do great. Okay, I can do maybe one more. This looks a little bit scary maybe with all these negatives. So this would be 6 divided by 2. Right, we've got our 6 divided by 2, which is just 3. And y to the negative 6 minus negative 4. Right, when we divide powers to the same base, we subtract the exponents. So when I think of subtracting a negative, we know that that means we're going to add a positive. So what do we get? We get 3y. Negative 6 plus 4 is negative 2. And then finally, we have to rewrite that. This guy has to come down to the denominator. So we get 3 over y squared. Okay, I hope you guys can work through this thought process. I would definitely try all of these. They're all a little bit different, but if you can get these 4, you have a really good understanding. Okay, and I hope you're having an okay day. I found this little comic. Where is it now? Whoops. Let me just see here. So for any parents out there, it says, oh yeah, homework helpline, I need to have you explain the quadratic equation in roughly the amount of time it takes to get a cup of coffee. So as you can see, this dad is calling the homework helpline so that he can help his daughter, and he doesn't want her to know that he doesn't get it. So if parents are trying to help their students and not sure, please do not despair. Just contact me. Okay, I'm still working as much as I can from home. I'm happy to email or phone or do some kind of Zoom chat. There's all kinds of online communications that we can do. So please, parents, don't get stressed out about this. And kids, you neither. Try not to do video games all day. Try to do a little bit of math. We're going to try and stay focused and keep a bit of a routine. I hope you're all well, physically and mentally, and I miss having you in the classroom. Have a great day, and we'll talk to you hopefully